Hello guys, welcome to today's lesson. I'm Kudienki Godfrey, a third year BSc Mathematics student of Kwame Nkrumah University of Science and Technology. Our topic for today is partial differentiation. So when you're given a multivariate function, say f of x1, x2, x3 up to xk. When we say multivariate function, that is a function of several independent variables. So when you have this function, you can find the partial derivatives of this function with respect to each of the independent variables, with the idea of holding the other variables constant. Okay, so from this function we can find the partial derivative of this function with respect to x1, x2. So when you are finding the partial derivative of this function with respect to x1, you hold x2 up to sk constant. The same thing applies to the rest of the independent variables. So let's look at the definition of partial differentiation. Okay, so let's consider a bivariate function, that is f of xy. That is a function of two independent variables. Okay, so partial derivative of this function with respect to x, that is at point xy, is given by the limit as h approaches 0, f of x plus hy minus f of xy, all divided by h, provided the limit exists. Okay, so the partial derivative of this function at the point x naught y naught is given by, so you substitute x naught y naught into x and y. Okay, so partial f partial x at x naught y naught is given by the limit as h approaches u, f of x naught plus h comma y minus f of x naught, y naught, okay, x naught y naught, all divided by h, provided the limit exists. Similarly, we can find the partial derivative of this function with respect to y. So partial f partial y at xy is given by the limit as h approaches u, f of x y plus h minus f of xy, all divided by h, provided the limit exists. Provided the limit exists. So at point x naught y naught, the partial derivative of this function with respect to y at this point x naught y naught is given by the limit as h approaches 0, f of x naught y naught plus h minus f of x naught y naught, all divided by h, provided the limit exists. Okay, so that's the definition for partial derivative of this function. Okay, so let's look at some basic notations. So when you have z to be a bivariate function, that is f as a function of x and y, the partial derivative of this function, that is z subscript x, is given by del z del x, and this is the same as f subscript x of xy, and it's the same as del f del x of xy. Similarly, the partial derivative of z with respect to y is given by z subscript y del z del y, and is the same as f subscript y of xy, and is the same as del f del y of xy. Okay, so these are some of the basic notations. So in our next lesson, we will solve examples relating to this topic. Thank you.